Write once post-it note. I cannot write on it more than once, right? I can write on something, but I cannot erase it, I cannot change it, I cannot overwrite it, and that's all the value it is, right? And I'm going to find the total of everybody's age in this room. And to find the total, I'm going to ask each of you to do some work. So the first thing I'll do is, I will take the first post-it note, I'll put a 0 on it, because 0 is the age of everybody I know, and I'm going to give him the first post-it note. It's not smiling anymore, right? No, I'm not going to ask for your real age, right? So he takes the first post-it note, totals his own age to the number I gave him, which is easy this time, it's 0. But wait a minute, he cannot write on this post-it note. What are his options? Take a new post-it note. So he creates a new post-it note, puts his age on it, because his age plus 0 is still his age, and passes it down to you. What do? You take the post-it note that he gave you, add your own age to it, and put another number on it and pass it to her. What does she do? She takes her age, subtracts 10, she has to do that, right? And totals the age she has received so far, no cheating the ages here, and then passes it down. Does it make sense? And as we do this, the gentleman right there in the back of the room, the post-it note he gives me is going to have what? The total of everybody's age in this room, right? So that is an example where we did not change any existing object. Imagine for a minute, I could have asked you all to come to the wall and erase a number and write on it again. That is mutability. And if you do that, then you tell all the 30 people to finish. But we could do this a little differently. We could ask each person in each row to do the totaling. And while each row is concurrently totaling, we could then go to the people in the last row here and say, whatever you receive as a total in each of the row, pass it down to the back. So now we have reduced the time. It's like a map reduce, isn't it? So we can have each of the row do this concurrently, and then we can take the corner information and then reduce it down. And so we can reduce the time it takes to compute the total as well. But the beauty of this is, because Horizontal takes care of it, you could say, wait a second, if that is the case, are we going to tax the garbage collector? That is possible, but we don't have to program that way. What we could do instead is, we could use a collection, like a trice, which will very nicely manage data. In this particular example, it's single data, so it's not that expensive. But if you're dealing with a collection of data, then that could become very expensive in garbage collection. But there are data structures specifically for functional style of programming that can ease the memory usage by making very selective copying. This is kind of like a copy on write proxy kind of a pattern that they implement under the covers to do it. Excellent question. So that's basically what it does to do this. So how would we put this in code? So I'm going to say prices.fold left, and what value did I give you to begin with? 0. You guys are paying attention. Great. I give a 0. And to this I pass another function. This takes accumulation and a current element as a parameter, and it returns back an accumulation plus the element as parameter. So as a result, you can notice this gives us the ability to do the totaling. Let's understand how this is going to work before we can go back and understand, run the code and play with this. So if you notice in this case, what I'm doing is I'm going to print the total 2. So let's go ahead and make a copy of that. And let's say in this case, I'm printing the total 2. What's happening in this case? The fold left method takes 2 objects. The first object is 0, right? Which is the initial value that I gave him. The second object is not just an object. The second object is a function itself. It starts at this curly braces and runs until this curly braces. That function itself takes 2 parameters. It takes the accumulated value and the current element in the collection. So the very first time when you call the fold left method, it takes the initial value 0, binds the accumulator to 0, binds the E variable to the first element in the prices, which is 10, and our code returns accumulator 0 plus p, which is 10, and returns a value of 10. And when it returns a value of 10, for left then receives that value, turns around and calls that function one more time, because there's more elements in the collection, and this time the accumulator is bound to the result from the previous call, which is 10. A is bound to the second element, which is 20 in this case, and so it totals and returns it, and then we turn around one more time, and then we keep looping through this until all values are exhausted. And finally what we receive from this call is the total of all these values, which better be the same as the total that we did in the imperative style of coding. So this gives an opportunity for us to really use a more of a functional style of is a list of tests that we can think of. Now we have to come up with a few tests to write. But don't spend your time thinking about what are all the tests we could write. That's going to take a lot of time and effort. Sometimes the best time to think of tests is as you're writing the test. So start with something to begin with. One of the biggest challenges is breaking the inertia. And so start with some tests. It's okay, we can refine it as we go along. And when it comes to starting to write the test also, you want to really focus on the core class and the core logic that you want to start. The other side will be with rules. So what would be a very simple test to start with on the rules? Can you think of something?
Out of bound array.
Say that again?
Array out of bound.
Array out of bounds. Now that is, what kind of test would that be of the three tests that we talked about? A negative test. I think it's easier to start with a positive test, right? So that probably is useful, but it's better to start with a positive test. So what's the simplest test we can think of for a rules game?
Number of players.
Number of players, but even more simpler than that, just to get started, right?
Does it run?
Can you place a peg?
Can you place a peg on the board? Okay, let's twist that question just a little bit. When is it that I cannot place a peg on the board?
The board doesn't exist. Board doesn't exist.
Well, the board doesn't exist. We could say, does the board exist? Or we could say, rule, game is not over. If the game is over, I cannot place a peg, right? So that's another way. It may not exist, but existence of it is not a problem, because when you're writing a test on a class, it is going to exist. And when will it not exist? Well, if you may do a new and make it out of memory exception, but how rare is that? Very rare, right? Most of the time you're going to get the object. And even if you're going to get out of memory exception, that's most likely not going to happen in your test case. In a I'm going to write here. I'm going to say, first is, game not over when created. So my first test is, the rule, first of all, we'll call it rules, equals new rules, and assert false rule start is game over. So I'm going to assert to make sure the game is not over to begin with, right? What's going to happen to this test now?
Venkat Subramaniam, founder of Magic Development Incorporated. This is my second visit at the Chennai Java user group. It is a pleasure to be with this group. I had a wonderful opportunity to speak at this group last year. We did a code retreat this year and also had a summit. The audience are extremely interactive, enthusiastic, eager to learn, and a charm to work with. I love being here, and I look forward to being here next year as well. Thanks for having me.